Hi everyone, I'm Dennis, and today we're going to talk a question in Euclidea 1.7. This question is talking about how can we draw an inscribed square in a circle. If you've played Euclidea before, you probably searched up YouTube videos talking about this, but they're just talking about how to do it, but they did not explain why that's the right way. Today, I'm here making a video explaining how my thoughts are and how I think that is a good way to explain how to get 7e. First, let's find out how to make 6L. 6L is pretty easy. You just make a line here and then it will extend and you will find this point. This point A is basically the opposite 100 degrees of point B at the top. So if you do the perpendicular line between A and B, you are gonna find out point C and point D. And if you connect these, you're gonna find an inscribed square. So that's how we do 6L. But how can we do 7E? 7E is harder because you cannot just use normal perpendicular ideas to think about this. So let's start. The first step we did is we make a circle like this. For example, I make this point A and this point O. We use AO as the radius, and then we use A as the center to make a new circle. Why do we do that? Because we need to find the 60 degrees. And if we connected these three lines, we're gonna find out that this is actually an equilateral triangle. How do we know this? Because they all have the same radius of the two same radius circles. So we now know that each of them has a 60 degrees on the three angles. But why should we know that? Because if we want to find an inscribed square, we need either 90 degrees or 45 degrees. 90 degrees is impossible because we cannot use perpendicular ideas, so it's banned. So we can only use 45 degrees. So how about let's just make a 45 degrees at the bottom. For example, I make a tangent line. Tangent to the point is showed here. Now I know this is a 90 degrees angle. In order to find a 45 degrees, for example, I draw a line here. This is a 45 degrees angle. We can separate it into two parts. One is 30 degrees. The other is 15 degrees. So what you can do is think of this, because you know that this line, this line, as I draw in blue, has the same radius of this, so they have the same length. Also because they have an exterior angle, 60 degrees, you should know that this is a 30 degrees angle. This is also a 30 degrees angle. So we now solve the question of 30 degrees. We solve it. Now we only need to find 15 degrees. So I'm looking at this 30 degrees angle, thinking if this 30 degrees angle is an exterior angle, then I would able to find this 15 degrees of angle, right? That's why I make a bigger circle. If you look at here, I make a circle based on this become as the center, and the length of this becomes the radius. Because I want to construct an angle, a triangle with 30 degrees as the exterior angle, because I know the radius of this has to equals to something here. And if you look down, you see I connected in green lines. I extended this line to make it here. Now, this line has the same radius of this. They have the same length. They are both L. So we successfully construct an isosceles triangle. Isosceles triangle. And then if we connected these two lines, we can find that, oh, we found the 15 degrees. So we find the 45 degrees of the angle here, which is obviously telling us that this point here has to be one vertex of the inscribed square. As you can see here, I connected these two points, so I successfully construct two lines of an inscribed square. Now here's the hard part. I connected this point with this. Why I need to do that? Because now I need to find the 45 degrees of this side of the square. I need to find here as 45 degrees, but I don't know. How should I find this is 45 degrees? As you can see here, as I draw in red, this line has the same radius of this line. They have the same length in red. So this is another isosceles triangle with a 30 degrees as one angle of it. So the left two, which has the same angle, is 75 each. As I know here is 30 degrees, it is easy to see that here is 45 degrees. As I know this is 45, I just know that this line is the correct line for me to construct a right line for the square. And the next step is to connect all four lines. That's how I think of this question. If you have any questions or ideas, you can show in the comments. Thank you very much.